Hi, everyone. My name is Gabe Lenetsky. I'm a business development lead here at Keysight Technologies. And today I'm going to talk a little bit about what solutions we have for quantum networking. So a high overview of Keysight, we have a pretty broad portfolio of solutions for quantum research. From our test and measurement solutions, we have, a lot of oscilloscopes, network analyzers, arbitrary waveforms, and photonic and optical types of instruments for research, as well as quantum control systems. And we have a lot of different software platforms from Labber, which I'll be talking about, Pathwave, and our quantum benchmark software. So overall, we're looking at the entire quantum ecosystem from early device development, such as designing qubits or things on chips that require advanced design and simulation tools, through early R&D design, through cryogenic calibration and component testing, to quantum control systems and scaling the systems for actual, large-scale quantum computing. But so for the purpose of quantum networks, we have three main focus areas. The first being classical network testing. We probably have one of the most comprehensive portfolios for classical test solutions. So we offer full network tests across all layers, from the physical layer through to the application layer, including software-defined network and network function visualization tools. And then from the actual quantum network component testing for, when there's a need for testing, say, QKD networks, we have test and measurement, photonic and optical equipment that can be used there, as well as individual quantum device characterization and so on. And then as this industry starts to go towards more photonic integrated circuits, we have, wafer probing test systems as well. So overall, we have, a pretty broad focus area, but I'd say we're interested in working with quantum network companies to help, further the standardization of a lot of the metrology that goes into quantum networking. So I'll talk a little bit about what we can help provide today. We have our Labber control software, which is made up of three different servers. The first is this instrument server, which is a hardware driver instrumentation server where you can, write your own drivers for Keysight or non-Keysight hardware to start controlling it using Python API. And then you can begin actually controlling that instrument and running tests. So you can create your own measurements and run your own test sequences using the measurement editor. And then as you get more data, you can this gets stored in this data analysis server called the log browser. And you can look at that data for fast analysis, or you can share that amongst your colleagues, things like that. So this is a way to help users, help universities and national labs get measurements quickly and start analyzing them. And so I'll talk a little bit about what off-the-shelf hardware we can provide today. So on the right here, you're actually seeing a demo of the Labber software using the hardware that you're seeing on the left. So what you're seeing on left is a single photon setup where we're using we're generating single photons using an optical laser source that is highly attenuated through an optical attenuator. And then those single photons are then sent through a polarization controller to create discrete variable photons that then are sent downstream to, say, a polarizing beam splitter. And those can either be measured using a power meter, or those can, in this case, we're actually using ID Quantique single photon detectors to measure those single photons and actually generate keys. So what's happening on the, going back to the software window, you can actually see that we're able to configure the log browser and measure things like quantum bit error rate or just the overall errors in our system. So what we've done and what we've in our lab is actually is providing a way to quickly set up a system like this to calibrate it as well, because we know that optical fiber does require some calibration. So I've referenced some papers here up top to different academic research going on in QKD using some Keysight test and measurement equipment. I've referenced my email here below. I'll be at APS March next week, so I'd love to meet anyone who's interested in talking about quantum networks. And if you have any additional questions or interests, you can go to our website at keysight.com/find/quantum. So yeah, thank you.